Okay, now that we've created our iterator, let's put it to use in implementing some secondary methods. Okay, in particular, we're going to use it for copy. Flip, we might use it indirectly for flip. Okay, but before we do copy and flip, let's get the easy ones out of the way. Is empty just means does depth equal 0. So we just say return depth equals 0, right? Okay. But we have an error there. What is our error? Depth cannot be resolved to a variable. It's saying it cannot find a variable called depth. Well, that's because there is no variable here called depth. This is a abstract class, so we have to implement these as secondary methods. That means we don't have direct access to any implementation. All right. But what we do have access to is we have access to the primary methods. And even though there's no variable called depth, there is a method called depth. All right. And then it says, okay, return depth equals 0. I'm sorry, we need a depth equals 0. All right. And then we do a similar thing for full. The stack is full when the depth equals the capacity. So we're going to return depth equals capacity. And that was easy. Those two methods are finished, and they are secondary methods. They don't rely on any particular representation. If we implement a list stack, these methods will still work. So this is their default implementations. Now we're going to do copy. And for copy, we're going to do it just like we showed in these slides. All right, we're going to iterate over the current stack, and one by one, we're going to push the iterated elements into the new stack. So the first thing we need to do is we need to create a new stack. And normally you would do that by saying, okay, stack e result equals, new my stack, right? But again, we don't have a representation here. So this is an abstract method. We do not have a constructor. So the way you can get around this is we have implemented a method called new instance. And a new instance will give us a brand new stack with the same capacity as the existing stack. So we just call this new instance, and bam, we are done. Okay, so the only thing we know about this new stack result here is that the new stack is empty and that the new stack has the same capacity as the old stack. That's good because when we want to do the copying, all right, we want to make sure that all the elements fit into the new stack. So we talked about using the iterator like this. Okay, let me show you two ways of doing this. Here's the old-fashioned way of using iterator, and it's old-fashioned, but it still works, and you still need to use it sometimes. So you would say iterator e. I'm just going to call it iter equals this dot iterator. Okay, and I see it didn't find it for me because iterator is unresolved, but we're going to import it. It looks like there's two different iterators in Java. We want the one in Java util. All right, and then we can do while iterator has next. We can do e element equals iterator next, which gets the next element. And then we can push that next element onto the new stack. So we can do result dot push element. And then we would return the new stack. We would return, result. Okay, and this is one way of using an iterator to get the elements from bottom to top in succession and then push them onto the newly created stack. Okay, the one we want to be a copy. However, I'm going to comment this. Okay, because the stack that we created was iterable, that means we can use the enhanced for loop in Java. And some people call that a for each loop, because you can simply go for e element in this, which this is the stack, and now you have access. Basically, for each element in the current stack, you can simply push that element onto the result. And that's it. It's even shorter than using the normal iterator. Okay, we had 4 lines here. That reduces to 3 lines, and not only that, but we don't have to worry about has next and next. You cannot always do this, but when you can, you should do it, because it's less code, it's easier to read, and you're less likely of making a mistake when you do it this way. So I'm going to scrap that, and that method should work. And by the way, now we don't need this iterator anymore. All right, so with that under our belt, we only have to do the flip method, which reverses a stack. And again, go back at the slides if you don't understand this method and look at how we're going to do this graphically. We said we are going to, all right, let me see if I remember. We said we were going to make a copy of the stack and put it in into a temporary stack. So this dot copy. All right. And now both stacks have the exact same elements, but we actually want to clear the current stack. We want to empty that. So we're going to clear it. And then we're going to go through the old stack, and then we're going to push all the elements from, then we're going to go through the temporary stack and push all the elements from the temporary stack into the new stack. We're not going to use an iterator for this because iterators go from bottom to top. So we just want to remove all the elements from one stack and put them in another. So I'm going to do this. While temp, actually while temp is not empty, I'm going to pop an element from temp. And I'm going to push it onto this stack. And that should do it. Okay, while the temp stack is not empty, you take the element off of the temp stack, you push it onto the new stack, you keep doing that, and the stack, the elements will come onto the current stack in reverse order. All right, so those are the secondary methods that we needed to implement, but we still need to worry about the overriding the object methods equals hash code and toString, and that's what we're going to do next.